Hi, this is Josh from Spokestack, and today I'm going to walk you through the process of setting up Spokestack Android in your project. And by the end of this, we'll have a working demo with full voice interaction. It's not going to be a lot of voice interaction, but it'll show you the key features of Spokestack and how to do a complete setup. All right, so let's look at some code. So the first place we'll start is our Gradle file, our dependencies. And I've written this project out ahead of time because no one wants to sit here for an hour and watch me type. But I will go through everything in pretty close detail so you'll know everything that's required along the way. I'll start up here at the SDK version. I have it set to 21. You can go newer if you want to only run on devices that are more likely to respond quickly to voice control, but devices as old as 21 should be okay. Below that, you'll start to have problems setting up TTS with the automatic TTS player that we use. There is a workaround for that I can post details on. You know what? So let's start in our Gradle file to see the dependencies that we're going to need to set up Spokestack. Now I've written all this out ahead of time because no one needs to sit here for an hour and watch me type, but I will talk about everything as we go through it so that you have a good idea of everything that you need. The first thing we're going to start with is our SDK version. I've set it to 21. Below that, you might have some trouble with the dependency for playing TTS audio back automatically. There is a workaround for that I can post details on if you're interested. Let me know in the comments. But 21 is a pretty safe number. This covers about 95% of devices at this point in 2021. So you shouldn't have too much of a problem with this. If you need to support older devices, let us know and we can work with you. So let's go on down to our dependencies. Notice here that we are using Java 1.8. A lot of projects use this by default. Actually, Android Studio set this up for me by default, so I don't think you'll have to change anything there these days. Our core Spokestack dependency is down here. At the time of this video, we're at version 11.4.2, and to use Spokestack, the key thing to understand is that Spokestack is a modular system. There's a module for handling the speech audio and turning it into text. There's one for taking that text and turning it into an action that your app can use. And then there's another one for turning text responses from your app into audio to play back as voice prompts. And so those modules are called the speech pipeline, NLU, and TTS. And depending on, you can use all of those, you can use one of those, you can use two of those. Depending on which ones you use, you will need different optional dependencies. We set it up this way so that you can keep your app slim if you only want to use one small part of voice control, or you can just have the whole thing. So these first two are for TTS, and specifically they're for letting Spokestack automatically handle TTS playback. You can choose to handle it yourself. We'll send you a URL and you can use whatever media player your app is currently using if your app already has a media player. In that case, you won't need the EXO player stuff. And then TensorFlow is required for wake word detection, waking your app up with a certain word. Keyword, which is keyword recognition, is a type of ASR that you can use for a limited vocabulary if you want to do on-device ASR that way. And it's also used for NLU. So you're probably going to want TensorFlow unless you're only using our cloud TTS service. There are a few other optional dependencies that you can read about in our documentation. We won't need this. We won't need them for the demo that we're going through today. They're only if you want to use different ASR providers. So you can include an optional dependency on Google Cloud Speech or Azure Speech if you need those for your app. But we're going to use the default on-device Android ASR, so none of that's necessary. Let's jump over to the UI. The UI, if I can even call it that. It's really two text labels and a microphone button. This is just so we can see what is going on with our demo when we actually speak to it. So this is going to be the ASR output, the speech that the app heard, and then we're going to use a simple NLU model that we provide for free on the Spokestack site to turn that into an intent. And then the microphone button, which will activate or deactivate the speech pipeline, or ASR, if we want it to. So let's take a look at the code we will need to set up Spokestack. I'm going to switch on over to my main activity here. And right off the bat, I'll say that when you have a complex app with multiple activities, you probably don't want to set up Spokestack in each one. You'll want to set it up as kind of a singleton and access it from your various activities as you need to. For an example of that, you can take a look at our Spokestack tray repository, which is a UI that lets you inspect your voice interaction as it's happening. It's a way to drop in a single fragment into your app and have full voice control with a little UI to let your user see what's going on with very little effort. But it makes use of the singleton pattern that I'm talking about here. But for this demo, we're just going to do a single activity and have everything all in one so it's easy to look at. At the top of this activity is just Android basics, logging, view binding, and we have to request permission to record audio at runtime, so we need a little Sentinel value to tell us which permission we were just granted. And if it's this one, then we will know to keep going with Spokestack. This is our Spokestack instance. And I will say again that Spokestack is modular, so you don't have to use an instance of a Spokestack object. You can use our individual modules, speech pipeline, NLU manager, and TTS manager if you want to separate things up and have full control. But this is an easy demonstration, easy first use type of object. Spokestack sends off events when different important things happen, when ASR becomes active, when text is classified, when TTS is playing, things like that. And we will need a listener to handle those asynchronous events and make the UI respond accordingly. For a few of our modules, we will need external files, TensorFlow Lite models, and NLU metadata. And what I've done for this demo is I've included these files in the assets folder over here. And so that will bundle them up in the app bundle and compress them there. So we'll have to extract them at runtime at first launch. We'll just put them in the cache directory. So it's a trade-off that you get to decide which is better for your app, whether you want to distribute them along with your app bundle and then update your app whenever you update the models, or if you want to download these models at runtime. We serve them at Spokestack from a global CDN. So it's about as fast as you can get them from us if you want to download them at runtime. But that's a decision that's best made on an app-by-app basis. So going on down to onCreate here, this is where we will set up Spokestack. This is just view binding stuff. Our main function is build Spokestack. And once it's built, then we will check for microphone permission. This is going to return false the first time because the modal will pop up on first launch asking the user if they want to allow the permission. And when we get the result back from that, that is when we'll start on first launch. But subsequent launches, this will return true if the user has granted permission, and we'll just start there. But the thing we want to look at is build Spokestack. So I'll scroll down here. Like I mentioned, we have to make sure our models are extracted from the assets, from the app bundle at this point into the cache directory. I'll scroll down real quick and show you. It's just a matter of looping through all the files, making sure each one exists in the cache directory, and if any of them doesn't, we're going to go ahead and extract them. This is just input stream to output stream, send it to the cache directory, and call it a day. And once we have those files there, we can go back up here and pass them in our configuration. Spokestack is configured using a builder pattern, so you can set all your configuration unless you need really advanced stuff you can set all your configuration in one call chain like this. So we'll go module by module here. The default is to set up Spokestack to use a wake word and Android's on-device platform ASR. So that comes standard with Android phones these days. Different vendors will have different implementations, but the interface should be there for all of them. It's basically the ASR that Google Assistant uses. So for wake word, all we really need to do is supply it with the models. There are 3 different wake word models that run one after the other for maximum efficiency. We split them up into these are tiny model files. And we have to supply all of them. And then for NLU, we do the same thing. We need all these files. That's the TensorFlow model. This is the biggest TensorFlow file probably. And then some metadata, and it's the model's vocabulary that's used to tokenize, detokenize, things like that. And then for text-to-speech, we will need the application context to automatically play back audio. If you are not using TTS playback, if you already have a media player in your app, you can call without auto playback and still use TTS. Or if you don't want TTS at all, you can call without TTS. And you probably saw in that autocomplete list, there are several other without methods that you can use it to take out one or more Spokestack modules if you don't want them. If you choose without wake word, you don't have to worry about the wake word files up there. If you choose without NLU, you don't need to worry about the NLU files in your configuration. And we will need Spokestack client ID and secret key to actually do cloud TTS requests. So we'll send that here. And we will need a listener, like I mentioned, to receive Spokestack events. This is also a good time to mention that I haven't done anything specifically for this in this demo, but Spokestack speech pipeline, which is the part that turns speech audio into text, has a series of profiles that you can use to configure in one shot basically what components you're going to be using. If you want to use wake word, the profiles that use our wake word detection start with TF Lite wake word. If you want to use a different ASR provider, the end of the profile name will usually have the ASR provider that you're using. So the default profile we use is this Spokestack profile TF wake word Android ASR. And like I mentioned, that is going to give you a TensorFlow Lite wake word detection and the Android's on-device platform ASR. You can use Google ASR, you can use Azure ASR if you've included those optional dependencies. And for each of those, you will also need additional credentials. So in general, whichever components you want to use, you should look at the documentation for that component, and it'll tell you which of these configuration properties are required or are optional if you want to tune the components. But this is it for setting up Spokestack. Just a series of configuration properties that you can include or exclude based on which parts of Spokestack you need. So the next thing we'll need to talk about is the actual event listener. And I've done that in an inner class down here. This is, like I mentioned earlier, this is checking for microphone permission. And when it comes back, for the first launch, we will get the modal, like I said, and then we will get on request permission result. And if the user has accepted, we will start Spokestack. And in this case, since we have a wake word, starting Spokestack means that it starts listening for a wake word. It doesn't start ASR. It doesn't start actively transcribing text. That is Spokestack.activate. And I'll talk about that in the context of the listener, which is right here. So we have a Spokestack listener, which extends the Spokestack adapter. And this is what gives us all these functions to override. When you set up your Spokestack adapter, you get to pick and choose which events you're interested in there are different events sent by the different modules, the speech pipeline, NLU, and TTS. So for this demo, we're using all of them, so we're interested in all the events. Speech pipeline is going to be the most involved because you'll get events when it activates or deactivates, and that's again when ASR is actively listening versus when it's done listening. And what we're going to do in that case is we're going to change the color of the microphone icon. And then partial recognize and recognize down here are what you'll get when ASR is active. So most vendors, including Android's on-device ASR, will give you partial results. So it'll give you text as the user is speaking, each word as it determines a word. And so sometimes you'll see a transcript advance and then back up and change the previous word as the ASR makes a different decision, scores a word differently. So it's fun to actually transcribe that in your apps because it makes it look more responsive. It lets the user know this thing is actively listening and doing something while I'm talking, even if that doing something is just transcribing what I'm saying. But also let me scroll up to the transcribe function because we're going to put the text in one of our text fields in the UI, but we're also going to send it through NLU so that we can do what some people refer to as streaming NLU. So it's classifying a text for intent and to extract any slots, any entities that are in that utterance as it's happening. So this can be useful for updating a search UI as a user is adding or subtracting terms. Find me red pants, find me red Levi's jeans. Do those even exist? But anyways, you can have your UI be even more responsive by responding to those intents as they change. And then when we get a final transcript, I don't recommend you do this in your app, but we're going to do it in the demo. We're going to echo it back to the user via TTS. And so looking up here at the echo function, you do TTS through Spokestack via a synthesis request. And this also uses a builder pattern, just like the Spokestack object, because you can do things like change the synthesis mode. And I'll show you the different modes are text, which is the default, SSML or Markdown. And these are ways to adjust the pronunciation of your text if you have a difficult to pronounce word or if you find that the TTS engine isn't saying something the way you want it to say it. You can change the pronunciation on a very fine grain level. You can add pauses like that into your TTS responses. You can set phone numbers to read as digits, 555 1234 instead of 555 1234, things like that. We have documentation on how to do all this on the site, but it's very helpful to know. Oh, shouldn't have done that because also there's with voice. We have a free demo voice that we include with all Spokestack accounts, but with our maker account, you can make your own custom TTS voice and pass its name here, and you can get your app to read your text in your voice, which is pretty cool, if I do say so. And let me just skip down to the bottom and we'll look at our logging function. This is a generic logging function that takes events from all the different Spokestack modules and sends them to the same place. You'll notice if you look through the Spokestack adapter code that there are other logging functions. There's an onTrace for NLU events, but they all go through the trace function. Our other two events that we're interested in are NLU result, whenever a classification happens. And we're going to use just the intent from that classification. There are also slots that represent the entities involved in that intent, but we're just going to print the intent to our text label so that we can see that NLU is working. And we also have a TTS event that will send you events when text has been synthesized, and so you have a URL that you can stream. If you let Spokestack handle playback, you don't need to worry about that because we'll deal with that internally. But you also have the general error event and also different events for playback. We started playing TTS audio, we stopped playing TTS audio. You can use that for interactivity or responsiveness in your UI. Or, and we also have, and there's also the playback complete event here that, as I say up in this comment, if you want your app to resume listening after a response is played, so you're having an ongoing conversation with a user and you finish saying your piece and you want to get the user's reply right away, you can reactivate Spokestack here on the playback complete event. The assumption here is that you also have a flag somewhere else that you're tracking in your app to make sure that you should reactivate after this particular response, because there will be some that will end the conversation and you don't want to reactivate after those. But that's a dialogue management question for the app. And that does it for the code setup. So let's go ahead and look at the app in action. So I'll go ahead and get my phone up here and run the app. The first thing you'll notice is that the permissions modal will pop up. Sometime. There we go. Yes, allow. Spokestack. How do I make a Ruby?
How do I make a Ruby?
And so you can see that we did the wake word detection with the Spokestack wake word, and then it transcribed everything as it was happening, did classification, and read actually my own speech back to me, but read TTS audio. And there you have it, a full voice interface in an Android app with relatively little setup code, and you can handle all parts of the voice interaction, from transcription to classification and audible responses. So hope you enjoyed it. Let me know if you have any questions or feedback in the comments, and I'll see you next time. Thanks for watching.